So I'd like to welcome a really incredible panel of people to the stage for our next section. If I could just ask each of you to perhaps introduce yourselves and what you do for your company, that would be fantastic. To start first with Judy, to my right.
大家好我叫 Judy 我是来自于英伟达，我是中国区这个做解决方案架构的
Fantastic. And next, Rana.
Hi, Geraint. I'm Rana Gujral. I'm the CEO of Behavioral Signals. We build specialized AI engines that are behavioral and emotional savvy, and we apply that to a variety of intelligent AI products out there.
Thank you. And Liran?
My name is Liran. Thank you guys for coming here. I'm doing the product marketing at Hailo. Hailo is developing a very small and sophisticated deep learning chip for edge devices. Very low power, and we can talk about it later on, probably.
Fantastic. And last but not least, Dev.
Hi, everyone. My name is Dave Lewis. I work with a think tank called Digital Asia Hub. We're based in Hong Kong, but our mandate is Asia-wide. And we essentially study the kind of impact, social impact, economic impact, and political impact of the kind of technologies that some of my colleagues here are building.
Fantastic. Well, welcome. I really appreciate your time today. Okay, so let's discuss a few of the key topics in AI. Perhaps starting, Judy, with you, if you do not mind.
Okay.
With AI, what kind of innovation and changes can be brought to carriers who are working in this area at the moment, do you think?
是因为我是来自于 Nvidia 我在这个 Nvidia 里面看到我们的合作伙伴和我们的这个客户在这个AI 领域做了很多的这个成功案例。那么在电信行业里面呢，我们知道刚才在前面的介绍当中有这个爱立信的嘉宾，有华为的嘉宾，还有其他的嘉宾，也介绍了 AI 的技术。那么在电信行业里面的各种的 machine learning、deep learning 的这个应用，我们可以看到这个技术帮助我们的电信行业里面在很多的创收降低成本、提升客户服务提升满意度等方面都有很大的这个应用的这个场景。那么我在这里呢特别提到有一个应用场景，就是 Nvidia 的这个客户，我们在北美和亚洲的这个电信的这个客户里面，我们有一个应用场景，就是在真正的帮助客户在做这种网络优化。那这个网络的优化的应用场景呢，因为我们知道现在随着这种的4G、5G 的这个介入呢，我们的基站数量非常大。那么网络的这个质量里面呢，它有很多很多的 KPI， 成千上万的 KPI。那么以前我们的这个电信的客户，他会用传统的 machine learning 的这个方法来预测我们在某些场景下我们的网络可能出现的故障。那么现在呢，这些客户呢，他会用GPU 加速的深度学习的这个办法来做这种的预测，用深度学习的办法来对这个原有的算法做改进。特别的是，他们是用到深度学习的这种的 LSTM 的这种的网络。那么对原来的100多个就是网络这种出现的这个主要质量的 KPI 做了预测。原来需要1天的时间来训练这个网络，那么现在呢，它只需要大概1个小时就能够完成这样子的训练。那么同时在做 inference 的时候呢，对于我们整个的这个的可以做到几乎实时的预测出这种的这个特征，而且呢，我们的预测的这个出现的这个错误的这个概率呢，也是已经有显著的这个下降。所以在这个真正的这个网络的优化方面呢，在电信行业里面呢，我们已经看到了实际的用户。那么除了这种北美的这个网络的电信公司以外呢，我们在亚洲的电信公司里面，在网络优化方面，我们也会有用 GPU 加速的深度学习的办法来帮助预测的网络的这个 traffic 的流量的这种的预警。那所以呢，从我的角度上来看呢，我觉得AI 的这个技术在电信行业里面还会有更多实际的这个案例在落地。OK， That's it.
Wow, it's really so exciting to hear about the possibilities that you are describing there, Judy. So talking of exciting, perhaps Rana, we move next to you. I know your company, Behavioral Signals, works a lot around AI and speech recognition. I think this is one of the more fascinating areas of AI now and in the future. So maybe you can describe a little bit around, what this is for you and what your company is doing in this area.
提到do you mean the speech recognition?
Oh, I'm sorry, Judy. I was referring to Rana next to you. I do apologize. Sorry. But
Sorry.
please, I would love to hear your opinion.
Sorry about
shortly.
that.
No, that was my fault. Sorry.
Yeah, I mean, I'd love to hear about your view as well.
Please.
After, I think
Sorry.
I think it's definitely exciting. I mean, what's exciting is if you think about how AI has progressed over the last I'd say 10, 15 years. Voice interactions has been a big part of it, and there's obviously it's a powerful use case. It impacts user experience, it impacts how businesses operate, and it brings new use cases to fruition. And one of the biggest aspects of voice interaction that has still been lacking is sort of empathy and emotional intelligence. And so for us, so we're playing a role in that. So one of the things which we're also seeing is that just not that much a few years ago, I'd say between 5 to 7 years ago, NLP and ASR capabilities were considered cutting edge.
Sure.
And fast forward into 2019, they're considered to be a commoditized technology. I mean, they're very reliable and they're very predictable. And so with those things in place, now the next sort of the holy grail is understanding intent and understanding the state of mind. And that brings that voice interaction to a whole new level. So what we do is we analyze speech and voice conversations, and we deduce emotions and behaviors, and use a combination of emotion and behaviors to build specialized prediction engines. So for example, predicting the outcome of the conversation. So if it's a conversation between a debt holder and a debt collector, predicting if the debt's going to be paid or not paid. Or if it's a buy decision, predicting if the consumer is going to buy or not buy. But equally, we could also apply those classifiers into a doctor-patient conversation. And like, for example, we work with a company that caters to a platform that manages patients with depression. And depression is an epidemic, major epidemic, and suicides, especially in the developed world, is a growing epidemic. And so we can predict a propensity for suicidal behavior. And that's a game changer. So
Sure.
for us, it's taking the voice interactions to a next level, processing voice interactions from the essential dynamics of voice conversations, but also take it to the next level and go deep into intent, prediction, and making machines be more relatable to humans.
Sure.
In terms of how we think of as conversing with a human, and sort of bringing the machines to the same level.
Okay, so that's so fascinating. And sorry, Judy, back to you. Perhaps you do want to speak about this as well. No, no.
It's okay, sorry.
No, sorry. Okay, so Liran, perhaps over to you and thinking a little bit around how we deliver this, right? Because this is incredible technology that needs to get right through the network, to the edge of the network. And I know this is an area that your company works in. So maybe you could say us a little bit around how you are, going after this challenge and what technology you're using to help us deliver this type of incredible work.
Yes, so there are many challenges. I mean, let's start with the fact that you have a neural network that is doing some task. You train it on the cloud, either GPU, and eventually you have a 32-bit floating point on the cloud. Now, this is good on a large PC. Now, when you want to move it to edge devices, there are many challenges that you have to take into account. And usually in edge devices, you care about power consumption, right? Our mobile phone is operated on battery. It's very important for us, power efficiency. At the same time, we want more capabilities, right? So it's kind of a conflict. Impossible mission? Not necessarily. What we develop is basically this tiny chip, very small. The uniqueness in that one, it doesn't include any external memory. One of the bottlenecks of the existing solution is that they include a memory, external memory. Neural network includes a lot of data, transfer data inside the different layers. each time that you go outside, you have to pay with the power and latency. What we develop is a revolutionary chip that is not based on any GPU, any CPU, or any accelerator, that basically does the job very, very efficient. Tasks like this chip goes to automotive, for example, able to detect pedestrian detection, free space, for example. And while other solutions consume around 30 watt, this tiny chip does better in a less than 2 watt. So it's very scalable solution. Goes to automotive, goes also to IoT devices, very scalable. So I think we did manage to solve the challenges to the inference, and if you're interested later on, we can talk about the product, but not here.
Thank you, Liran. And so Dev, over to you. I guess maybe looking at more of a kind of macro picture on this, you know, what we are seeing now is many countries advancing really quickly in terms of AI and use of data. So how do you see this kind of playing out into the future?
Right. Yeah, thanks, Evan. Yeah, I mean, what we just heard, an array of products and services that AI is powering right from the morning until just now. And what we at Digital Asia Hub are doing is trying to better understand the larger, broad-scale societal implications, the changes, the economic transformations that will arise, and how will that affect things like labor, how will that affect politics, how will that affect ethnic conflict, because we're seeing these products being sort of delivered into industries every day, and there's a really need to understand that. And the thing is, if you look at the past few industrial revolutions, most of them have been led in the West, the so-called West, you know, Europe, Industrial Revolution, the United States with the computer revolution of the last 50, 60 years. And now, for the first time, you're seeing a slightly more diffused technology landscape. I mean, we are sitting here in Shanghai. You know, Asia is at the center of so many of these breathtaking revolutions. And there's a need for a sort of much larger, much more global discourse and dialogue about how do these societies in this part of the world think about these technologies. What kind of values do we want to build when we build these technologies? And so that's what my institute really does. And over the last few years, we've really seen a remarkable widening of this conversation around the world. I mean, I think 5 to 10 years ago, maybe this dialogue would have been happening mainly among, you know, industry folk, among a very close-knit community of engineers, of scientists. But now you have political scientists, you have social scientists, you have ethicists, all having this dialogue. In the last few years, we've seen an amazing proliferation of global discourse. This year, the OECD came up with principles around AI and ethics. We have the European Union. We have over 50 to 60 countries that all have national AI plans. There's a coalition called the Partnership on AI, which Digital Asia Hub, we're one of members of. And it's sort of coalition of private sector and civil society to better understand AI. And I'll end with one good example connected to what Rana's company is doing, right? Using voice recognition into and all these wonderful applications. As we learned, the data is central to all these machine learning applications. And the thing is that most of the data that exists in this world, especially with language, is in English. And English is, and so there's a disproportionate amount of data in English, especially, let's just say, American accented or British accented English. And so when you're building these applications and you're bringing them worldwide, especially doing some things like, you said suicide behavior, or like these kind of like emotional, personality-based risk analysis, there's a sort of a major risk emerging where you're building these technologies and bringing into societies, and maybe you don't have the right data sets for those societies, for those countries. You don't have the data sets for those languages. And so you have this emerging issues of bias that can emerge. You have issues of sort of false positives that can emerge, which I'm sure you all sort of you deal with and work on improving the algorithm. And so what we're trying to do is say, okay, how can we have a broader conversation? How can we build principles that can help companies like yourself think about the broader societal implications? What could a false positive mean to maybe a certain group of people who maybe are not as represented in the data sets? And so trying to get more data available, trying to work with people to say, okay, how can we bring more data and more languages to have these technologies more representative of different communities?
So interesting. And
add a
please, Rana,
quick to that? I think that's a great point, Dave. I think one of the things, we've obviously been having these conversations internally, and one of the things which we've been very largely focused on, so our core tech deduce emotions largely from intonations and tonality. So there is an aspect of deducing emotions also from what is being said, which is a speech to text. Yeah. But that's actually a very small portion of how we analyze emotions. So I'd say it's a 20% speech to text or actual words that are being used, and 80% is tonality, and that's somewhat language independent, right? So in fact, what we have seen is we take the engine and we applied it to a completely different language where we don't have an NLP, we don't have an ASR, and we're still able to get a fairly highly accurate read on the state of mind. And what you need to obviously do is to have some cultural biases be fed into the system, because different cultures, different countries, and different parts of the world treat with emotions differently. So once you have that baseline created, tonality and the variance in tonality and variance in pitch is largely similar across the world. And so this is one of the reasons why we focused exclusively on voice, and we haven't really started to dig deeper into other areas, because we feel that access to data and data that's equalizing and it's not biased in one particular industry segment is going to be key to delivering a capability that can be then consumed by humanity at large. Otherwise, as you said, those biases creep in, and once those biases creep in, those AI solutions are, in a sense, ineffective in the long term.
Yeah, that's fascinating. Yeah.
So interesting. So Judy, perhaps back to you. I'm just thinking about, again, how these services are delivered, and we use the word data a lot. So obviously this makes me think of 5G, which I know we are all very excited to begin to experience in our lives. But I guess 5G will require a lot of computing power to drive, right? So maybe you can give us a little flavor of what you're working in this area to facilitate 5G and other technologies.
Okay. 那 GPU 在这个5G 当中的应用，因为我们知道 GPU 在加速这种 AI 的这种技术、深度学习，包括现在的机器学习方面，起到了非常关键的这个作用。那么在5G 的整个的这个发展过程中呢 ，GPU 在数据中心这一端呢，仍然会在对深度学习、机器学习的模型训练，包括大数据的处理方面，发挥着这个很重要的作用。因为我们的 GPU 在这个主要的一些 AI 的这种的模型方面的这个训练方面，我们有这个业界最好的这个 MLPerf 的这个 benchmark 测试的这个最好的这个记录。那么在这个应用领域里面，我想在5G 的应用当中 ，GPU 仍然发挥作用，这是在数据中心端。那么现在随着5G 的这个网络这个不断带宽的不断增加，延迟的降低，很多的这种的计算呢会移动到边缘。那么在边缘端的这个计算里面呢，我们要提供各种各样的服务给我们的最终客户。那么5G 的应用里面呢，我们也知道，我们现在刚才提到了有这种的有 AR、VR 这样子的应用。那么也有很多高清的 Ultra 高清的这种内容，4K、8K 的这个内容，也要给到我们的客户端。那么同时可能会有很多在万物互联的当中，我们这 AI 的应用来做推理。那么 Nvidia 的 GPU 除了在整个的加速计算当中呢，我们能做很强的这个推理高吞吐量、低延迟的推理以外呢，那么实际上 NVGPU 本身在做图形的处理方面，这是我们的这个本项啊。那在 GPU 里，在加速这个应用当中，在边缘计算的领域里面的 AI 的应用、VR 的应用，包括 gaming 的应用，那么对于高清视频的这种分析、推荐等等，这本身是 GPU 的这种的有很大的这个长处，尤其在这种的。这游戏方面，我们对于这种很特别效果的实时的光线追踪方面 ，GPU 有一些特别的技术。这是在边缘计算方面，这个 Nvidia 的 GPU 可以在做对加速5G 应用的，从生活到工作各个领域的应用都能够实现这种加速。那么除了在这个边缘端，在这种设备端，在这种的device 端里面呢 ，NV 也有这种嵌入式的这个产品这个嵌入式的产品对自动驾驶机器人自动设备的这种智能处理方面 ，inference 方面 ，NV 也做了很大量的工作。那么同时呢，在 整个5G 的这个发展过程当中呢 ，NV 现在跟很多大的Nvidia 跟很多大的电信公司，其实在以前在传统的用 CPU 或者用 FPGA 加速的一些应用领域，比如说是 VNF 领域里面呢，实际上我们也有很多的合作，也有很多大的电信公司在 Nvidia 在这方面把传统的从CPU 上面做的计算来转到这种的GPU 上。我们可以看到，我们不仅在速度上面有很大的提升，我们在整个的完成部署方面，整个应用的这种的落地方面也有是非常的快迅速这就是我们谈到的在 GPU 在整个5G 的应用，在数据中心端，在 Edge 端，在 Device 端，在整个传统的电信的这种加速数据处理端，我们是都能够提供全面的这个应用和发展。谢谢 ，Thanks. Okay.
Fantastic. No, thank you. It's a great overview. I love to talk about these use cases of 5G and the way you describe things for gaming and other areas. It's so fascinating. But maybe Liran and Dev as well, if you could help us kind of think through some of the other exciting ways that this technology can be used. Perhaps Liran, starting with you, like how will we actually use this technology?
Yes. So Nvidia is doing many things. And it does it very well. Gaming, training, those kind of things. But actually, this is a problem, because if you are doing so many things, and we are here in an AI summit, and we want to do something to accelerate the AI specifically, then you need to think outside of the box. I'll give you an example, and without going to too much technology, because this is not the place. But in terms of application, let's take, for example, automotive, for instance. Autonomous driving will include a level 4 and 5, will include around 30 sensors, right? All kind of LiDAR, radar, vision, and so on. In terms of the application itself, we would like to be able to detect a person, pedestrian, from far distance, for example. The issue today is that the current technologies cannot process the full-scale image. If you have a full HD or HD image, you have to downscale the image in order to meet real time. So you need something that is able to process this very efficient, and again, with low power. This is one of the things. Things like, let's talk about Europe, GDPR, for example. There are some regulations that will be also on cars, what kind of application you need to have in this one. GDPR, not all the cameras that you have can transmit the data. What happens 5G, for example, if you have a car, you cannot rely on 5G, on critical mission tasks. You have to do things on the edge devices. So yes, some of the things can be done on the edge, on the cloud, but most of the things need to be on the edge devices, and there is a lot of constraint, let's say.
Sure.
That's
really interesting. And Dev, perhaps thinking about it more of the consumer perspective, what kind of uses of 5G technology do you find exciting? How we will be living and working in the next coming years with the technology?
Well, I mean, personally speaking, I'm absolutely excited for looming 5G, and I can't wait to see how many gigabytes of TikTok videos are going to be shared every minute on these super fast networks. But I think 5G is an interesting technology because we just heard these wonderful use cases with especially autonomous vehicles and what that's going to power. Like 5G is also the center of a sort of, let's just say, a global geopolitical storm, if you will, where I think all countries are starting to realize or look at how these technologies are going to evolve and what stake they're going to have on the economy. And it's really interesting to see, I mean, looking at AI, looking at 5G as well, if you look at from a geopolitical context, you're actually seeing a lot of emerging risks emerge where you're looking at economies that have not made that, are not at the cutting edge of getting value from data. Mm-hmm. And they don't have companies at the cutting edge building value from data. And then you have a big split happening where sort of countries in the low end of the value chain, especially in South Asia, Southeast Asia, who don't have right now these sensors, right, across different industries where they're picking up data firstly, then build these products and build these solutions. And they're essentially now having to look at bigger companies, global companies, whether it's in China, whether it's in the US, whether it's in Europe, to sort of buy these products and buy these solutions. And then there's question marks about how they're going to even get value from their economy, how they're going to build employment in these countries. And so it's one of those sort of the big question marks. And so right now we're seeing with 5G as well, with AI as well, of how these sort of data poor countries are able to sort of build the right policy landscapes to then just sort of benefit as much and make sure that they sort of you don't see a sort of even further sort of digital divide that's emerging at the moment, which I think is really fascinating. I mean, I think we'll see these companies, 5G companies will in China, elsewhere go global, but you're also seeing the sort of emerging rift between the sort of data-rich and the data-poor countries.
Okay, and Rana, just kind of building on that and thinking about as we move into the future and what this might look like. How deep do you think our understanding can go, even of ourselves using this kind of technology? Do you have any feelings around where this may be in the future?
In particular about 5G? Or
Around the work you're doing in terms of speech recognition, understanding how AI can help us understand ourselves as humans as well.
Well, I think, it's a great question. I'd say one thing people miss most times is that the AI is everywhere. And it's more prevalent than what we imagine it to be. Essentially, one way to define it is to give machines and non-human entities an ability to do things which currently humans are better at doing. But obviously, there are limitations to our capabilities in terms of processing vast amounts of data or compute powers, and so those are things machines are better at today. And so you see those implementations in play. But I think the more exciting aspects of AI will come in when we're seeing an impact on user experience. And it will come in subtle ways, right? In certain subtle ways in terms of how we call a company and how that query gets responded to by a virtualized entity that completely understands us without any wait time. It's super accurate. It's not making any mistakes. It's empathetic. It understands the state of mind. It has all of the data that it needs to make that accurate decision at its disposal. And that would be a completely new level of user experience, right?
Wow.
And that's real today. It's possible. It's getting there. You have conversational chatbots. Granted, they're chatbots, but the next level up is conversational voice assistants, which are just as conversant, and you can't tell if it's a human or a non-human behind the scenes. Now, the bigger use cases are around disease diagnosis, like Watson, and that's phenomenal, right? But people think, is that going to replace a doctor? I don't think so. What it will do is it will allow doctors to focus on what really matters, which is essentially, treating the patients and sort of empathizing with them rather than focusing all on the diagnosis part, which can be automated.
Sure.
So I think those things are coming to play. It's really exciting, it's see how those use cases come up in the next 4 or 5 years.
Definitely, I cannot wait to see what will happen. So you've all shared some really incredible insights today, so I really appreciate that. I'm sure the audience do. Maybe just to finish, if I could ask each of you just to maybe give kind of one area or one idea or piece of research that you would suggest for the audience to go and explore in more detail around AI or 5G or whatever application we've talked about. Maybe if I can ask each of you just to kind of give one suggestion to our audience. Again, perhaps starting with Dev on the end.
Sure. I think one of the most exciting areas that I look at and we've been researching is taking the level of machine learning applications and moving beyond data. So essentially improving algorithms and essentially making AI more intelligent. And we've all seen our colleagues here build some wonderful products which are at the cutting edge. There are a lot of machine learning scientists who talk about how building AI systems that essentially can move beyond just learning from heavy sets of data. Because if you compare the learning process, what a child learns in a few minutes, sometimes machine needs many, many lifetimes of data, let's just say, to sort of make those some inference and insights. And so I think for these, so thinking, let's just say, thinking with the hat of, let's say, developing countries and sort of emerging countries where, going back to the data problem, the lack of data sets that are available, I think algorithms that are able to sort of build the same insights, smarter algorithms that are not as reliant on data sets, those are some of the really sort of cutting edge research that's happening. I think that's a field that I think will bring about a big change, because right now a lot of the debate is countries with data are going to be the ones advancing, countries without will be the ones falling back. But I think these kind of new learning methods, which perhaps there are people here in the room who are also working on as well, might change that dynamic, which I think will be really fascinating to see.
Fascinating. And Liran, next to you, what is one idea you would suggest people to go and research more?
The issue I hear all the time, people are using AI, machine learning, deep learning, all this kind of thing, which is a big kind of a mess inside. We have the AI, which is the ultimate goal, where everybody would like to be there. This is where the machine will be able to learn by themselves. They will be able to solve problems. But guess what? We are not there. Everybody is using outside AI, but we are not there. Then there is a subset of this one, which is called machine learning. Machine learning is the ability to give a machine to learn without explicit kind of rule-based. And then there is a subset to that one, which is called deep learning. And we are there right now, and we are using neural network for that one. Why I'm telling you this one? Because we are just at the beginning of all these things. What you see outside is object detection, all kind of classification, all those kind of things. Interesting, but what can we do with that one? Not many. Think about the bigger picture. Smart cities. Camera will be able to identify if people are fighting inside the home. We don't want to transmit data. However, I have 4 kids. I want to know if they are doing something wrong, right? So I want to get alert without damaging my privacy. So think about behavior, those kind of things that will help us kind of in the big picture. This is where I would like to be, and still keep our privacy clean, let's say, safe.
Makes sense. And Rana, over to you. I mean, maybe in another example, perhaps in the area of business, perhaps how this technology could be.
Yeah, well, there's a lot to be excited about. I think the area which I touched on a little bit earlier, I'm personally most excited about is predicting outcomes.
Sure.
And this is, so for example, if you think about, when we say we made a decision based on our gut, what is a human gut? Is human gut really random, or is it based on certain data? It is based on a lot of data that we have, and it's unstructured, unprocessed data that we accumulate together to make a decision. And we're now able to codify that into software programs. And some of the things, like for example, as I said, so one of the engagements we worked with a leading speech analytics company, and they gave us a challenge. So they operate heavily in the debt collection market, and so they gave us a challenge, and they said, could you take this 15-minute voice conversation and predict the outcome? And we were not given access to any CRM because of privacy concerns, or any sentiment analysis engine. So it's simply by listening to that voice conversation, we were able to predict with over 82% accuracy if the debt holder is going to pay their debt or not going to pay their debt. And that's a game changer, right? So once we have those classifiers, now we're looking to apply that into a variety of different use cases. And in a way, what we're doing is we're taking the human gut, and we are putting that into an AI engine, and we're saying we're going to predict outcomes. This is essentially like a mini crystal ball, which would say, what's going to happen here? And the engine tells you an answer, and that's relatively accurate as it stands today. Possibilities are endless. I'm very excited about that, and we'll see where that goes.
For sure. And Judy, perhaps again, from your perspective, what one key idea that you would recommend to our audience to go and do some more research on?
我看到过 AI 应用领域在各个方面，因为我也听到我们刚才就是各位专家也讲到 AI 的应用领域在各个行业里面，图像、自然语言理解、语音识别等等这方面有很多的进展。那我也听到了，就是里面提到我们有很多的用户，我们有很多开发者由于在数据准备方面，可能会是在开发技能方面的限制，可能会在人工智能应用的发展方面有一些局限性。 那实际上我是想，Nvidia 在这个方面呢，其实做了很多的 AI 的一个技术的普及，来促进大家能更容易的来对这种 AI 技术的发展来做出一些更深入的研究。那么我想给大家就是，如果是 AI 的从业者、AI 的开发人员，如果想那么在 AI 的应用领域里面做一些很多的发展的话 ，Nvidia 的有一个网站叫 MGC。Nvidia GPU Cloud 这个里面有很多我们提供好的已经有预训练的模型有图像的、语音的、自然语言理解的，有最先进的这种 BERT 的这个模型。那么在这上面呢，你可以呢就可以在我们 GC 上面下载这些预训练的好的模型，或者说是你的这个 Model Script， 来帮助你在应用的各个领域里面做深入的这个发展。好，谢谢。
Fantastic, so interesting. Fantastic panel. Thank you so much for everything you've shared. So thank you, Judy, Rana, Liran, and Dev. I really appreciate your time. Please give them a round of applause, and thank you very much for your insights.
Thank you.
Thank you.